Hi everybody, in this lecture we are going to be going over numbers. Just like we went over strings, numbers also have their own properties. We also have a lot of methods that we'll be going over. So let's get started. JavaScript has only one type of number. Numbers can be written with or without decimal. I think we have already seen that, but let's go over it once again. So variable x is equals to, let's say, 34. You can write it either 34 or you can write it 34.00. Either ways, the answer would be 34. And it will be a number. Number with decimals. I will just reassign the value to x of 34, which is not a decimal. So a number without decimals. Similarly, we also saw exponential numbers. So I can also write x is equals to 123e5, which will give it a value of 1, 2, 3, 1, 2, 3, 4, 5. And x can also have a decimal exponential format, which is x minus 5. In that case, it will be 1, 2, 3, and then I need to move it 2 decimals on the left and then a 0.023. We've already covered this, so you can definitely do that. Now a little bit theory before we move ahead. So JavaScript numbers are always 64-bit floating point numbers. Unlike other programming languages, JavaScript does not define different types of numbers like integer, short, long, floating point, etc. JavaScript numbers are always stored as double precision floating point numbers following the IEEE 754 format. So IEEE 754. This format also stored numbers in 64 bits. So before even going into what 64-bit is, let's just understand that computers always understand the language of zeros and ones. So anything that you see in computer can be represented as a combination of 0, 1, 0, 1, 0, 1 or 0, 0, 0, 0, 1, whatever in that particular format. It's all bits. And what happens when you have a 64-bit? You have 64 positions to fill in a 0 or a 1. That being said, if you have a number that you need to represent, the first 0 to 51 bits will be taken up by the number, which is the number would be represented at the base of 2. So that let's say, for example, if you need to represent 1 in terms of the number, it will be 0, 0, 0, 0 times whatever, and the last digit would be 1. Similarly, if you need to represent a 2, it is usually 0, 1, 0, and so on and so forth. This goes on till like 51 bits, and the number of bits you can keep on adding here. So that's 0 to 51 bits. But again, you don't need to understand this. This is a very integral detail, but it's good to know information. Now, 52 to 62 is pretty much the exponent, and the 63rd bit is the sign bit, which means you can have positive as well as negative numbers. And that's why if I just give a positive or a negative sign, it will straight away work. Okay, enough of this theory. Let's get to some actual experimentation with numbers and see where we land up. So let's say I have a number x1 is equals to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Similarly, I have another number which is x2 as 9s, but this time 16 times. So this is 15 times 9, and this is 16 times 9. I just wanted to show you a very peculiar behavior that JavaScript has, where it starts to behave abruptly after a particular point, and this is without decimals, just the normal numbers. So let's try to do a console log. Console.log. Let's do x1 comma x2. Let's just close this output. We don't need it anymore. Let's open the console. Let's just clear it, run it. The first output that you see is 15 nines, which is accurate, what we gave in for x1. However, the next output seems to have 17 digits and it has been incremented by 1. What does that mean? Well, the problem is that integers or numbers without any period or an exponent notation are considered accurate up to 15 digits in JavaScript. So you can definitely vouch for what will happen up to 15 decimals, and after that it's pretty much an abrupt behavior. However, we won't need that big of a number in real life. 15 digits is very big number. But just keep in mind, if you see an absurd behavior, it's because of JavaScript internal workings. Similarly, we also have the maximum number of decimals is 17. But floating point arithmetic is not always 100% accurate as well. So if I want to just check on how the decimal numbers will be, it will be accurate till like 17 digits, and after that it will again have a very weird behavior. Now, there is a very disturbing equation that I'll just show you now. So let's say x3 is equals to 0.2 plus 0.1. And when you do a console log, what do you expect out of this? Well, the answer is very, very, very easy, which is 0.3. But let's try and put it onto the screen and see what happens. Oh, the answer is not 0.3. It is 0.3 and 0.04. What is this? Well, again, JavaScript has some uncertain arithmetic computation. It's not always 100% accurate. So in this scenario, how to avoid such mess? Well, there are multiple ways, but one of them is you can, instead of 0.2, you can just do a 0.2 into 10, 0.1 into 10, which means convert them to numbers first and then divide it by 10. So this should actually give you the same decimal point where you wanted to. And let's try to clear the console and run. And the answer is 0.3. Yeah, I know it's weird, but that's how JavaScript is at times because of the floating point arithmetic. Okay, we already talked about the bits, which is a base of 2, which is zeros and ones. There are some other concepts too, or the other ways to represent a particular number. Well, the one is base 2 we already saw, and it's called binary because it's all bits. The next one that we have is hexadecimal, and hexa, as you can understand, it means 16 to the base of 16. So all the numbers are represented up to the base of 16. Instead of zeros and ones, you can use numbers till 16, and I think it's till 9, and then you start with A, B, C, D, E, F. I think F. Similarly, you have base 8. So this is base 2. This is base 16. Then you have octal numbers, which is base 8. And of course, you have the decimal numbers, which is base 10, and that's what we use in our day-to-day life. So what if you want to represent these numbers into these particular formats? Well, JavaScript has got you covered. Again, we won't be needing this for the most part, but if in case you need it, there is a way to do that. So let me try and show you an example. So let's say if you want to convert a variable x4 is equals to 128 into all of these formats, the way you will do it is x4 dot toString, which means you will convert it to a string and you will give the base, which is 16 for hexadecimal. Let's actually do a console log. Hexadecimal value is, let's close this, let's do x4 dot 16 and let's close this bracket. So hexadecimal value will be here. Let's try to give octal, which is 8. Let's output this. Let's also do binary, which is 2, and let's see what we get. So hexadecimal value of 128 is 80, octal value is 200, and the binary value is this. So what if you want to assign a hexadecimal value? For instance, let's say we have a number 255 and you want to make a hexadecimal value. So what you will have is hexa is equals to 0x, and that's how you represent a hexa number. It's 0x and ff, which means it covers all the bits of a hexadecimal. Now we can also do a console log where we will say decimal value is hexa of 10. Let's clear this and let's run this. Well, the value is 255 as I mentioned. So be careful when you assign a value or a number to a particular variable. It should never start with a 0. So let's say if you want to have a value of x equals to 7, don't ever give it as 07. So avoid 07, just give a 7 and that should be good enough, because if you give a 07 it may consider to be an octal value. Okay, we have been doing a lot of math, from multiplication, addition, division, etc. So what if there are corner scenarios? Because even in mathematics we have something called as an infinity or a divide by 0. So what happens in this scenario? So whenever you have a very large number that you give in JavaScript, probably the largest number possible, in that scenario the JavaScript will assign it a value of infinity. Yes, the exact word infinity. And similarly, when you divide something by 0, instead of doing the actual division, JavaScript will return infinity for you. So let's see a very quick example. So variable x5, I think that's what we haven't used yet. Let's do 2 divided by 0, and let's do a console.log. Let's do infinity test. Let's clear the console and let's run it, and the answer is infinity. Similarly, if I need a negative infinity, I can just do a minus sign here, clear it, run it, and it will give me a negative infinity. Let's go ahead and see the type of infinity. So let's do a console.log, let's do type of, and let's type in infinity. Let's clear, let's run, and the answer is number. So yes, infinity is actually considered number in JavaScript. That brings us to another very good concept in JavaScript, which is not a number. Let me write the full form, not a number. And what do I mean by that? Well, NaN or not a number is a JavaScript reserved word indicating that a number is not a legal number. Trying to do arithmetic with a non-numeric string will result in a not a number. So let's go ahead and see an example. Variable x6 is equals to, let's say we have 100 divided by 100, and let's do a console.log x6 and then see what the value would be. The answer is not a number. So what if instead of 100 I gave it a string 100? Let's see that example as well. So let's give this an x7. Instead of 100, let's make this a number 100. In this scenario, the answer should be 1. Oh well, I did not do the console log of x7, so the answer is 1. There is also a very good way or a method that JavaScript provides that can help you test if a number is not a number, or probably if it results into not a number. So let's go ahead and check this for x6, which is already a not a number. We have defined that. So let's put it to test. NaN, you pass in the parameter of the number, which is x6 in this scenario, and let's see what the result would be. The answer would be true, which means it's not a number. Now, if I do the same thing for x7, the answer should be false because it is a number. We already saw that it's false. Here you go, it's false because we already have the number 1. We already saw one very good property of numbers, that you can concatenate it with a string, or probably if just the way we use 100 and the digits 100, we can also do addition and subtraction using the same thing. So let's say we have another variable x8 is equals to not a number. variable x9 is equals to, let's say, 5. Now variable x10 is equals to x8 plus x9. Now what happens out here? What will be the value of x10? What do you think? Because if it were, let's say 3, let's see the value of x10, and then we'll go ahead and do it with not a number. So the answer would be 35, because it takes 3 and it adds the string, which is 5, so it concatenates the string. Now if you give a not a number out here, clear the console, run it, it will give you nan5, which means it will just be a string and it will have no significance as a number. And just like infinity, if you do a type of nan, it will still give you a number. The type is still a number. Okay, let's move on to another concept, as numbers can be objects. Just like strings, numbers can also be defined as an object. So you can very well have a new number 10, that will be 10. You can also use x12 is equals to 10. And just the way we had same problems with strings, we can have problems with declaring a number, because it slows down. New keyword also will be a problem, and it's definitely writing less code when you directly do x equals to 10 versus x equals to a new number of 10. And just like strings, JavaScript numbers created using new number cannot be compared because they are of type objects, so they'll have the same problems as we had with strings.